So we're going to graph this quadratic function, and we're going to use the form and the properties, and so it's kind of the best of both worlds. Okay, so first we got to get it in the form. So we have f of x equals 3x squared minus 6x plus 5. Okay, so set the 3x squared minus 6x aside, and put that 5 down there. Factor out the 3, because we need a leading coefficient of 1 inside the parentheses. And now we'll have to find the number that will complete the square. So you're going to take half of 2, which is 1, and 1 squared is 1. Okay, but remember, you didn't really add a 1. You really added a 3. So now you need to subtract 3. Okay? So back it up, rewind that part if you need to, but that's kind of the tricky part. All right, now we're going to get the form 3 times x minus 1 squared. It's minus because of that right there, plus 2. And now I know my axis of symmetry. I know it's right side up. So I know it's right side up. I know the axis of symmetry. Can't spell it, but I know it. Is going to be x equals 1, because h is 1, okay? And then the vertex is going to be at hk, so 1, 2. So the k is 2. All right, let's start with that then. The axis of symmetry is at 1, where x equals 1, so right here. Another thing that might help you is remember the vertex is always going to be on the axis of symmetry. So then my vertex is at 1, 2, which is right there, that point right there. Okay, and we know it's going to be right side up. Okay, now let's see about finding some intercepts. So I'm going to take the form that they gave me originally, and I'm going to find some intercepts. So this goes back to what we did in 9.6. Now, if you're wondering, could I use my new form that I just found to find the intercepts? You can. I just don't think it's as easy to do. All right, so first we'll find f of 0. This will be the y-intercept. Okay, so we get the point 0, 5. And that's going to be the y-intercept. Okay? So 0, 5. 1, 2, 3, 4, 5. Right there. Okay. Now, that means it's right side up, right? Because we already know the vertex is 1, 2. So that's as low as it's going to go. So that's handy. Also, because we know the y-intercept, we know that it's going to be, there's going to be a, I'm sorry, not because we know the y-intercept, well, we do, but there's a symmetric point right on the other side. Won't let me draw it, but it's right over there. Now, by looking at this graph, we know it's right side up. We know where the vertex is. What can you say about the x-intercepts? No x-intercepts this time. Okay, so I'm not even going to bother like with a quadratic formula or anything. I know there's no x-intercepts. Now I only have 3 points, so I'd really like another point. Maybe I'll put in like the next point over. So I'm thinking like right here, which is what, 1, 2, 3. So I'm going to find f of 3, and let's see what that gives me. Hopefully it's not too big, but this does have quite a stretch on it, so it might be kind of big. We'll see. See what we get. All right, so 3 times 9, yeah, that's already 27. But I get to subtract 18, so let's see what happens. 27 minus 18 plus 5. So I'm getting, what, 9 plus 5, which is like 14. It's a little large. It's kind of like up here someplace. And then there's one on the other side, over here. It's a little off my graph, but I'm kind of estimating it. that happens when you get a stretch like 3. It doesn't take much to get it really stretched, and then it's really skinny and you get these large numbers. If it had shifted, down, then it would have fit better. But okay, that's how we're graphing it then.